Hi, my name is Raphael Sparge, and I'm the founder of GreenWish. I'm very proud to present to you Is There Hope for Planet Earth? Many thanks to the California Institute of Contemporary Art for the generous support that made this possible, as well as the California Institute of Technology here in beautiful Pasadena, California. And finally, to Professor Jess Adkins for the work he does every day.
My name is Jess Adkins. I'm a professor here at Caltech. I'm a geochemist and a paleoclimatologist. I work on the history of the Earth's climate, and I do that trying to understand how ocean chemistry changes through time. It's very fun as a scientist to be working in a field that you're passionate about, and to have that field also matter to many folks on the planet makes it even more fun, right? I mean, I get out of bed in the morning thinking, okay, it's today the day I figure out why there are glacial cycles. One of the really neat things about being a scientist is you get to discover stuff and find stuff out. Sometimes problems are really complicated and there are too many moving parts to see. Climate can be a lot like that, but there are some parts of it that we just know, that are just true. And if you hear people denying these particular parts of it, they're making a political point. They're not making a scientific point. We know that CO2 is going up faster than it ever has in geologic history. It's also true that the planet has been getting warmer since the Industrial Revolution, and we understand the basic physics behind how that CO2 would act to warm the planet. And so that part is indisputable. It's not an important debate to have of whether climate change is happening right now or is going to happen or happened in 1968. In 2050, it will be warmer because of CO2, and no one will be arguing about that and will be wondering, what were we doing in 2014? What is global warming? That is a pretty simple answer. That is those things that warm the planet. It turns out that there are really only three ways to change the mean temperature of the planet. First is change the sun. If the sun gets brighter, we get warmer. If the sun gets less luminous, then we get colder. If we get far away from the sun, we get colder. If we get closer, we get warmer. The second way is reflect more or less of the sun's energy. Okay, but neither of these two are CO2. The CO2 comes in number 3, in this thing we call the greenhouse effect. And this greenhouse effect is often described, and not incorrectly so, as somehow throwing a blanket over the Earth. So, how do we get a grip on what might be to come? Here is what CO2 looks like over the last glacial cycle, the last 120,000 years. And what's really interesting is that instead of writing PCO2, I could write sea level. Or I could cross this out and I could write temperature, and it looks basically like this. This is one of the first ones that I would worry a lot about. We know why sea level went up and down in the temperature. It's because glaciers got bigger and smaller. And so as we were getting colder like this, glaciers were growing on top of Canada. And as we got warmer like this, the glaciers went away. Sea level went down by 125 meters when the glaciers grew. We still have a couple big glaciers around, the one on top of Antarctica and the one on top of Greenland. Greenland holds about 6 meters of sea level change. The West Antarctic ice sheet holds another 6 meters of sea level. And the East Antarctic ice sheet holds something like 50 meters of sea level left in it. Just to give you some perspective, if sea level went up by 6 meters, that would then take out most of Florida. Manhattan and New York City would be mostly underwater. Most of Bangladesh would be flooded, huge chunks of Indonesia. We'd have mass migration of millions and millions of people. That would be hard to deal with. Probably the second one that I would say that we should pay attention to is precipitation. The thing that we tend to tell people is that where it rains, it's going to rain more, and where it doesn't rain, it's going to rain even less as we go forward with global warming. Notice neither of these two are actually the warming themselves, right? The mean temperature of the planet is not something I'm actually all that concerned about. It's some of these knock-on effects, and that's why it's so much harder for scientists to give you the prediction. A lot of climate change discussions end with fear and the sky is falling and that's it, we're done, we've ruined the planet. I don't think that that's true. I mean, I think it's true that those conversations end that way, but I don't think they have to. I think that we can actually think better about that. We've put the CO2 in the atmosphere, we can take it out. We actually know of technologies that can pull CO2 out of the atmosphere, and then we need technologies that help us store it down in the ground. That is the kind of technological solution that if more folks in the country said, yes, this is something that we want to try to do, we'll naturally end up developing a market. We are addicted for very good reasons to these fossil fuels because it's really good. It is excellent at powering an economy. We carry it around in our gas tank in the car, and the instant that you decide you want to get onto the freeway and start accelerating there, you break a whole bunch of chemical bonds that were formed millions of years ago, buried in the earth, brought out, put into a refinery, put into the back of your car. So at the very moment that your brain said, now I want to go faster, you can. That's awesome. I mean, that is a really cool technological thing. And sun and wind, these sorts of alternative energies, they're not that. They're not a fuel. Sun and wind and hydroelectric, these are energies that they come when they want, right? It's when the sun is shining, it's when the wind is blowing. One of the big next technological advances is going to have to be, what are the battery technologies? What are the energy storage technologies that will allow us to use alternative energies just the way we use fossil fuel energy right now? One of the questions that always comes up when you start talking about climate change is, what can we do? And if we is you sitting at home or going to work, one of the most important things that you can think about is, how much do you use? What do you consume? And do you need to consume that, or are there ways that you can consume less? It's easy. I tell my kids this all the time. When you walk out of a room, turn off the lights. If you go out the back door, shut the door. Take shorter showers. You can also join a local social club, and that social club might be environmentally oriented. You can start your own Greenwish chapter in your town if you don't live in one that has a Greenwish chapter. There are many people around who want to do better, just like you do, and getting together and doing things together will make a difference. All of these things, many of which you've probably heard time and time again, I'm here to tell you, they matter. It's okay to do them. Conservation matters. My daughter came home the other day. We do a lot of sports on the weekends with the kids, and so there are empty Gatorade bottles around. And she said, oh, we have to reuse these bottles. And I thought, oh my gosh, where did she hear this, right? But she didn't just hear it, it mattered to her. And she went and collected all of the Gatorade bottles, and now we have a little Gatorade bottle corner, right, that we're gonna reuse them for the water bottles for the next weekend. You don't have to explain this stuff to kids in any sort of complicated way or talk down to them, whatever. Kids feel that they can make a difference, that they can do things to change the world that they live in. I find that unbelievably empowering. One of the reasons I think it's fine to be optimistic about finding solutions to climate change is that we have good examples of things we've already done. If you go to corals in Bermuda and you drill into a coral head, you can get back 200-300 years of history of the coral growing up, just like tree rings, and there's very, very little lead in the corals until the Industrial Revolution. And you can then just start to plot the curve of lead rising in the corals in Bermuda as the Industrial Revolution comes on. There's a sharp rise as we get into the World Wars, a little bit of a pause, and then as the American era comes on, there's a very steep rise coming up into the 70s. And in 1972, when the Clean Air Act was enacted, the lead in the corals turns around. And it has been dropping and dropping and dropping and coming back down to those background levels because the Clean Air Act specifically went after catalytic converters and the type of fuels that we use, and we've been putting less lead into the environment. Good laws make for good solutions. Climate change, for people who work as scientists on the problem of climate change, can also be scary for them, right? But I don't have a bunch of scientific friends who are walking around scared all the time, right? And have a twitch that's come on because they're so nervous about what's going to happen. Is there hope for the planet Earth? Absolutely. We need to unleash the creative and entrepreneurial power of our country. It's kids, it's teenagers, it's 20-somethings. That's where all the great new ideas, all the great new energy is going to come from. Creative people in their garages coming up with some great new thing. If we don't tell people what it is that they need to solve, they're not going to solve it. But if we tell people, hey, this is really important, get focused on this, it's amazing what people are going to come up with. Of course you have to have faith in the human capacity to solve their own problems. I mean, you have to be an optimist to be a scientist.